This question, you're supposed to calculate the current flowing through the circuit. But over here, you have the resistors in parallel connection and then the cells in series connection. So first, we are going to calculate for the total resistance. And the formula for finding the total resistance is 1 over RT equals 1 over R1 plus 1 over R2. So we have the 1 over RT equals 1 over 3 plus 1 over 3. So we have 1 over RT equals 1 over 3 plus 1 over 3. We are going to get 2 over 3. And what we are going to do next is we are going to reciprocate for both sides. So when we reciprocate 1 over RT, we are going to have RT equals 3 over 2. And 3 over 2 will give us 1.5 ohms. So we have the cells connected in series. In order to be able to find the total voltage, we just have to add in 7.5 plus 7.5. It's going to give us 15 volts. Then we move on. Potential difference equals current times resistance. We know that we are finding our current, so we divide both sides by R in order to make current the subject. So R cancels R. I equals V, which is the 15 volts, divided by 1.5 ohms. And when we do our division well, we are going to have 10 ampere. So that's the current, 10 ampere. The second part, we have what are the diagrams represent. The diagrams represent electronic components, and they label the parts A to D. So A is a resistor. This is a symbol, and this is how the real life resistor looks like. B is a field effect transistor. C is an integrated circuit. And then D is a bipolar junction transistor. So we have to state the function of the parts A to D. So A, which is a resistor, limits or regulates the flow of current in a circuit. B, it controls the flow of current between two terminals by varying the voltage applied to the third terminal. Then C, which is an integrated circuit, can perform a lot of functions depending on the design. It can amplify a signal or control a signal. And then D, which it is used to amplify current and switch electronic signals. Types of D. We have NPN transistor and NPNP transistor. So with this question as well, we are asked to identify A to Z. So A is the fuse, B is the cable grip, wire X is the live wire, wire Y is the earth wire, wire Z is the neutral wire. State the color of each of the labeled wires in modern electrical appliances. So the wires, wire X, which is a live wire, is brown in color. Then wire Y, which is the earth wire, is either yellow or green, or sometimes you see yellow and green. Then wire Z, which is the neutral wire, is blue. Say the function of the parts labeled A. So the function of the fuse is it protects the appliance by breaking the circuit when there is overload of current. It also prevents damage and fires as well. Then what is the function of the diagram about? So this whole diagram, the function is that it shows the internal wiring of a plug, and it demonstrates how different wires and components are connected for safe operation of electrical appliances. Read the circuit diagram below and answer the questions that follow. I says, name the components X, Y, and Z and state their functions. So X is a variable resistor, Y is a voltmeter, Z is an ammeter. Then the next question says, what effect would a reduction in the number of cells have on alpha, the current in a circuit, and then beta, the voltage. For alpha, which is the current in a circuit when the number of cells are reduced, so the current will decrease. This is because the current in a circuit depends on the voltage provided by the cells and then the resistance in a circuit. So with fewer cells, there's less voltage to drive the current, resulting in low current. Now with the voltage will also reduce. Each cell provides a certain amount of voltage. So reducing the number of cells will reduce the total voltage available in the circuit. So decrease in voltage leads to a corresponding decrease in electrical potential difference across the circuit. The last question, gamma says state two changes in the circuit that would increase the brightness of the lamp. So the first thing is increasing the number of cells. When you add more cells, you increase the voltage, which will lead to a higher current and a brighter lamp. Secondly, decreasing the resistance of the rheostat. The diagram below shows a device which is the weakest part in any electrical circuit. Study it carefully and answer the questions that follow. So A, we have a device here. You can see it's a similar one below. So I, which electronic device is illustrated above, is a fuse. The fuse is illustrated above. Then II. In a 3-pin plug, which wire houses this device above? The live wire. Then the II says, if device B is in an electronic appliance, at which current will the device blow, and explain. So device B, we can see 13 ampere. So the fuse will blow when the current flowing through it exceeds 13 ampere. And this is because the fuse's melting point depends on a magnitude of current. And a higher current will cause the fuse to melt faster. With the fuse, there's a wire in it. That's what breaks to stop the flow of current. When, for example, with the B, it exceeds 13 ampere. Then IV, which of the two devices above has a low melting point? So the 5 ampere fuse will have a lower melting point. Why? Fuses are designed to break or melt when the current flowing through it exceeds a certain rated value. So with a fuse having the 5 ampere, the rating is low, so it has a lower melting point. I, we are asked to identify all the circuit symbols from I to VII. So I is an ammeter, II is a voltmeter, III is a conductor, IV is a rheostat. Then I found this to be a circuit breaker, but we have something different here. We have this symbol with a line passing through. So if you know it, kindly comment in the comment section. VI is an open switch. VII is a resistor. Great. So state the importance of I, VI, and then VII. So I is used to measure the current in a circuit. VI helps to break the flow of current in a circuit. And then VII opposes the flow of current in a circuit.